Hi, in this video, I will show you a very easy way how to draw the two flip chair conformation. And when you follow this guideline, you should be able to draw some very beautiful chairs conformation. So let's go over the step. First step is to draw two slanted lines that are parallels. And it can be slanted to 20 degree or negative 20 degree. And one of the slanted lines should be shifted than the other. And if the line were to be shifted to the right, then the top line must be shifted right as well. So here's what this is saying. So first we draw two slanted lines. And here in this case right here, because we are slanted to the right, so in this direction right here, we will consider this to be 20 degrees to the right. And because we slanted this two line right here to the right, the top line should then be shifted to the right a little bit compared to the other. And that would then result in these two lines. And now on the flipped chair of it, in this case right here, it can be done by shifting this or slanting this negative 20 degree. And in this case right here, because we are slanting this to the left or negative 20 degree, the top line should be shifted to the left than the line from below. So that's how we would draw these two lines. And on the second step, we would imagine two horizontal lines that are touching the ends of the top and the bottom line that we just drew. And we would then mark a dot on this imagined line. And we would then, and this dot right here should be marked where it's distant. So the distance from this dot to the end of the line should equal to the length of the line that is already been drawn. So what this means is as follows. So again, imagine two imagined horizontal lines that is going through, and the horizontal line on top should be touching the higher point of the line on the top, versus the horizontal line that we imagining should be touching the bottom point of the line from the bottom. And that's what it would be. And here in this case right here, if the horizontal line were to be touching the right point of the top line, then now on the left of it, that way we would make the mark this dot. And the distance from this dot right here to the end of this line should equal to the distance that is from this end to this end right here. So that's what this is saying. And now similarly for the line below, so here is again the imagined horizontal line that we don't have to draw out. And now we're gonna mark a spot on this line. And where do we mark it? It will be because by doing the following. So here in this case, the distance from here to here is that much, and we're going to extend that distance going from over here, which this is where we're going to put that dot right there. And similarly for the other flip chair conformation, so this would then be the imagined horizontal line, and then again this will be that distance, and now we have to mark the spot from here to here have to be the same. So therefore that's where the dots would be, and this will then be the other dots. Once we have drew this dot already, the next step is to now draw lines to connect from the dot to the ends of the two lines that are already drawn. So from this dot right here that we mark, we now will be drawing this line right here from the end of a line already been drawn to the dot. And same thing here from the end over here to the dots. And similarly over here. And now we would have the two flip chair conformation. And by the time we are finished with our chair, our chair should contain three sets of lines that are parallel. And if they do not contain this three sets of chairs that are parallel right here, then that means that they're not very well drawn. So in this case right here, we can see the following. This line and this line are parallel. And then the two black lines here are also parallel as well. And the two lines here in blue, they're almost touching each other, and they are parallel as well. So that's how we'll be able to draw the two flip chair conformations of cyclohexane. And now let's now put in the groups. On each of the carbon in the chair conformation, technically speaking, each of this carbon right here is supposed to have 4 bonds, and right now 2 bonds are drawn out already. So that means there's 2 other bonds in each of this carbon. And now the position of this bond can be determined as following. And it's really important that we can determine the exact locations and draw them out very, very well, because the position of the 2 other group connected to each of this carbon right here matter a whole lot in determining the energy of the conformations, and that we'll see later. So the 2 groups for each of the carbon, there will be 2 groups connecting to them. One of the group will be classified to be an axial position, and the other one will then be classified at the equatorial position. And here is how we will be able to identify them. Now, so the axial position are basically the position that are parallel to the vertical axis passing through the center of the ring. So here is the ring right here, or the cyclohexane ring. And now imagine here there is a molecular axis passing through, and this would be vertical. So basically, the axial position would be the position on all of this carbon that are parallel to this molecular axis right here. For example, here in this case right here, on this carbon, there will be 2 groups connecting to this carbon, X and Y. So here in this case right here, the X position will be the axial position, making it a line parallel with regard to this molecular axis. And the other one, this position right here, this is basically perpendicular to the molecular axis. Not exactly perpendicular, but somewhat perpendicular. And here in this case, that would then be called the equatorial positions. And now, here are the position of all of the group connecting to all of this carbon. And we see the following. For each of this carbon right here, there will be an axial position. And again, the one that lines exactly vertical, that will be the axial position. So here will be the axial position of this carbon, and here will be the one on this carbon, here the one on that carbon, and so on. Now, some of this axial position right here are pointing up, whereas other are pointing down. So how do we draw them and determine which one is up and this one is down? And this can be done as following. Now, first imagine a plane that basically parallel to the plane of this ring right here. And when we imagine that plane, it will be in the middle of this ring. So this carbon right here, some of this carbon right here are considered to be pointing up with regard to this plane, whereas all they are pointing down. And here in this case right here, there are 3 positions that are known to be pointing up. So this one right here is pointing up with regard to the plane a little bit. This one right here is pointing up, and this one is pointing up as well. So there'll be 3 carbon that are pointing up with regard to the plane of the molecule. And there'll be 3 other that would be pointing down. So in this case, they're alternating. This one, and this one are pointing down. Now, so for the carbon that point up, its axial location will be pointing up as well. Versus for carbon that are pointing down, their axial position are pointing down. So that's how we can determine where the axial position would go for each of this carbon. So again, if we were to look at this carbon and if we were to draw the axial position this way, then that would be wrong, because this carbon is pointing down, so therefore its axial position should be pointing down. And this one right here, since this is pointing up, its axial position should be up. And this one will be down, and so on. So that's how we can draw the axial position on all of the carbon. And now how do we then draw the equatorial? So for each of this carbon right here, there will be one equatorial. And this equatorial right here, it is not perfectly parallel or perpendicular to the axis or parallel to this axis right here, but it basically slightly slanted a little bit, in which its bond angle is about 109. Now, so we'll be able to do it by doing the following. So from the axial position that we already drew, now we need to draw a line down and make sure it is 109.5 degree away. And that's how we'll be able to draw the axial location. And same thing over here. This is the axial position. So 109.5 away from here, that would then be the equatorial position. And same thing over here, and same thing over here. The two other that do not seem to be about 109 would then be this one right here, this two position. So in this case, this one right here is this way, and this one is in this way right here. So it's really important that we know how to draw all of the axial and equatorial position in all of the carbon in the chair conformations. And one thing to also take notice is the following. Let's say here is the left half of the chair, and so this will be the left half, and this will be the right half. For all of the left half, the carbon on the left half, for the equatorial position, so here in this case, and this is point up already, the axial point up, so the equator should be pointing down, and now I point down to the left. Same thing over here. This one right here, this is pointing down, so this means this will then be pointing up. And in this case right here, it up and to the left. And since this one right here, on this carbon, this one right here point up, so the equator have to point down, and now it point down as follow. And same thing over here, all of the equatorial position on the right side should be pointing to the right. And now with the up or down, depending on the axial location that we already drew. And in fact, all of this position right here can be classified to be on top face or bottom face of the ring. So imagine here, this ring right here being flat. All of the position on top, this is then called the top face, or also called the alpha face. And now this is the bottom of the ring. So this is called the bottom face, or the beta face. And we will then see the following. For each of this, in this chair conformation right here, we will then see the following. So on the top face, for each of this carbon, there will be one group that point up on the top face, and there will be the other that point down. So on this carbon, this will be the group that point up, and that means this will be pointing down. And now on the next carbon, this one right here, this is pointing up right here, and this one right here, they're pointing down, and this one is up, and this is down. So make sure we know how to classify the top face and the bottom face and all of the position that each of this carbon would have.